Hi everyone, welcome back to the lesson on probability. This is the second lesson on the topic probability, and we will be dealing with certain terminologies and the definitions associated with the topic probability, and also you will be able to determine the sample space and the event of an experiment by the end of the session. To start with, what is an experiment? We have seen the term experiment in many places. An experiment is an activity, and at the end of activity, you need to observe certain results. The results of an experiment are called the outcomes of the experiment. For example, the basic examples that we use when we discuss the term probability is tossing a coin. When we toss a coin, there are two possibilities of outcome. The first one is that you get a head. The second one is that you get a tail. Rolling a dice. If it is an equally likely dice, then you may get 6 outcomes. You may either get a 1, a 2, a 3, a 4, a 5 or a 6. Now, an unusual example of probability or an unusual example of experiment. Testing a spark plug from a batch of 100 spark plugs. What all can be the results? It can either be defective, it cannot be defective also. So the outcomes there are defective and not defective. Now comes sample point, sample space and event. Sample point is an outcome of an experiment. For example, head is a sample point when you consider the experiment tossing a coin. Tail is another sample point when you consider the experiment tossing a coin. Now, what is sample space? It is a set of all possible sample points of an experiment. So, the sample space of the experiment tossing a coin will be set, head, tail. Event. Event is a subset of the sample space of an experiment. For example, if you are tossing a coin and you are observing the result, and the event can be getting a head. Another event can be getting a tail. To get a more clear idea about the sample space and the event, we will consider this example. Suppose you are tossing 2 coins at the same time. What will be the sample space? You have 2 coins as I told you. There are different outcomes that you may get. You may get a head in coin 1 and a head in coin 2. The next option that you may get is a head in coin 1 and a tail in coin 2. The other option is a tail in coin 1 and a head in coin 2. Next option is a tail in coin 1 and a tail in coin 2. So, the sample space is a set of all possible results. If you express that head in coin 1 and head in coin 2 as HH, head in coin 1 and tail in coin 2 can be expressed as HT. Similarly, tail in coin 1 and head in coin 2 can be expressed as TH, and the last option as TT. So, what will be the sample space? It is the set HH, HT, TH and TT. Now, let's consider an event. My event E is getting at least 1 head. Now, in which all situations you are getting at least 1 head? At least 1 head means you should have at least 1 head in your outcome. You can have more than 1 head, but at least there should be 1 head. Now, we will consider each and every outcome that we have in our sample space. HH. Are we having or getting 1 head? Yes. HT. There also you have 1 head. TH. There also you have 1 head. What about TT? You've got 2 tails there. So there is no head. So what will be the event of getting at least 1 head E? It will be HH, HT, TH. This set is called the set of favorable outcomes when you consider that particular event. Now, union of 2 events. Union of two events E and F is the event E union F that contains a set of outcomes of E and or F. As events is a set, the union of events is same as finding the union of sets. When you find the union, you need to take all the elements from set E. You need to take all the elements from set F. There need not be repetition. Now comes intersection of two events. The intersection of two events, E and F, is the event E intersection F. And there you take all the set of outcomes which are common to E and F. That means which are present in both E and F. The complement of an event E is the event E complement. Thus, the event E complement is the set contain all the outcomes in the sample space S that are not in E. I'll see an example for all these concepts of union, intersection and complement. Consider the experiment of rolling a die. What will be the sample space? The sample space will be set 1, 2, 3, 4, 5, 6. Now I have given you two events. Event E is getting an even number. So E will be 2, 4, 6 as these are even numbers in the sample space. And F is getting an odd number except 5. The odd numbers are 1, 3 and 5. So except 5 means F is equal to set 1, 3. Now, what will be E union F? As I told you, as these events are sets, you need to combine the events or the sets E and F just as in sets. So E will be 2, 4, 6, 1, 3. When it is written in an order, it will be 1, 2, 3, 4, 6. Now here comes the second question. Compute E intersection F. You need to consider the events E and F and check which are the numbers common in both of them. Are there any numbers common? No. So E intersection F will be empty, or else you can say E intersection F is equal to null set. Now what will be F complement? Set F is equal to 1, 3. F complement will be all the elements of the sample space which are not in F. So you need to discard the elements which are in F. So the elements which are in F are 1, 3. So F complement will be 2, 4, 5 and 6. Now comes mutually exclusive events. Set E and F or events E and F are said to be mutually exclusive if E intersection F is equal to a null set. If there are no things common in between two events, those two events are called a mutually exclusive event. Now let's consider another example. An experiment consists of tossing a coin 3 times and observing the resulting sequence of heads and tails. Describe the sample space. We have done it for tossing a coin 2 times. So how it will be when you toss a coin 3 times? You may get 3 heads together, 2 heads and 1 tail, and so on. So the sample space is this: 3 heads, 2 heads and 1 tail. First one head, tail and head and 2 tails, tail and 2 heads, tail, head, tail, 2 tails and head and 3 tails. Our first question was to find the event in which exactly 2 heads occur. So in which cases you have exactly 2 heads? Here you have 2 heads, but there are more than 2 heads, so you cannot consider that. In the second case, you have 2 heads and 1 tail. So that's fine. Here also 2 heads and 1 tail, that's fine. Here only 1 head is there. Here 2 heads and 1 tail. Only 1 head, no head. So exactly 2 heads, there are 3 options. So that will be event E. Now, you need to find at least 1 head appears. So here there are 3 heads. 3 heads means at least 1 head is there. So you can consider. Here in the second case, you have 2 heads. Fine. Third case, 2 heads. Fine. Fourth case, 1 head. Fine. Next case, 2 heads. Fine. Next case, 1 head. That's also fine. Next case, only 1 head. That's also fine. And in the last case, you don't have heads. So that event will be all of that in sample space except 3 tails. So this will be event F. Let's do one more example. This is happening in a movie theater. The manager of a local cinema records a number of patrons attending a first-run movie screening. The theater has a seating capacity of 500. So determine an appropriate sample space for this experiment. So since it is having a seating capacity of 500, let's consider that he's recording the number of patrons from 1. So if he starts from 1, 2, 3, 4 and so on, it will be up to 500. So what will be the sample space? Sample space S is equal to 1, 2, 3, 4, etc. up to 500. There is a possibility that the screening can be done when there are no people. So sample space starts from 0. Determine an appropriate sample space for this experiment. We have already done. Describe the event E that fewer than 50 people attend the screening. So if it's fewer than 50 people, then it will be 0, 1, 2, etc. up to 49. So that will be event E. Now describe the event F that the theatre is more than half full at the screening. In order to determine the event F when the theatre is more than half full, we need to understand what is half full. Since the seating capacity is 500, half full is 250. So more than half full means F is equal to 251, 252, etc. up to 500. So this is the end of this lesson. Thank you.